Okay, well, we are running a little bit behind schedule, so I'll do my best to do the speed talk. But the end of this session will merge right into the beginning of the poster session. So instead of having a break between the two, we'll just move from here out into the lobby, and there will be snacks and drinks. And we can converse and talk more about density management. So my talk is in the same vein as the previous two, is that I'll be talking about landscape topics, but I'll be talking about connectivity. And so in a way, I'm trying to integrate some of the things that Robert and Janet have just laid out for landscape context with some of the other habitat issues that we heard earlier today. And so I'll be integrating habitats across spatial scales in a connectivity context. And connectivity is really important in a sort of a conservation paradigm for organisms as they need to disperse across large distances. So I'll be integrating some of the thoughts that we've heard already today. I'm also going to transition a bit from the terrestrial world that we've been talking about today into topics that will really dominate tomorrow. Tomorrow we're going to get our feet wet. We're going to be talking about riparian systems and streams for most of the morning. And so I'll be integrating a little bit of that now, talking about landscapes and watersheds. And then third, when we think about connectivity habitat, we're really talking about dispersal, and I'll be focusing my attention on some of the low mobility organisms that have trouble dispersing across landscapes. And already today we've heard from Bruce McCune that some of those organisms may be lichens. They have trouble dispersing across landscapes. And I happen to work with amphibians, and I'll be giving that example a little bit later. So let's see if I can go through my slides in sort of a speed talk and get us to the snacks out in the lobby as soon as we can. So some of the conservation fundamentals of connectivity is that you'd like to include redundancy of connections in your planning. And connectivity and redundancy of connectivity is important in a lot of network type of systems. And here's just some examples that when you lose connectivity in your electrical system or even in the communication system in your human body, paralysis happens, or you have a brownout, or your social network starts to die. And that's the same thing across landscapes. We want to find ways that we can design redundancy in our landscape planning to maintain connectivity across many different pathways. A good way to think about this is if we think about landscapes as watersheds, because watersheds are a way that we can cookie cutter landscapes into smaller and smaller cookies, and then use those smaller and smaller watershed cookies to maintain connections. So on this slide, it's showing a watershed, and if you look at the yellow circle, you're going up into the headwaters of the watershed. Headwaters permeate landscapes, and if you look over to that aerial photo of a clear cut, you can see lots of headwaters emerging in that aerial photo. Headwaters are across that entire mountainous landscape. Headwaters are small streams. They're everywhere, and we can use these small watersheds, small drainages, as a template for thinking about landscape connectivity, also integrating aquatic connectivity with overland connectivity. We know quite a bit about aquatic connectivity, and some of the talks tomorrow will talk about that. The riparian reserve network that we now have on our federal landscapes is touted as being really good for connectivity. It's really good for aquatic connectivity. But there's a gap between the end or the headwaters of those riparian reserves and the overland, over ridge connection that might be needed to bridge terrestrial connectivity to the next drainage. In this diagram by Hart Welsh that just came out about a week ago, He's indicating several of the processes and concepts that go into aquatic connectivity up and down the stream network. And you see a few arrows that are bridging across the land, across the streams, across bridge lines. And those are exactly getting at this overland connectivity concept that is needed for aquatic resources and also many terrestrial resources. At headwaters, we have the shortest distance over ridge lines, and so overland connectivity can be very feasibly done at headwaters. In this paper by Olson et al. In 2007, we started to design how you might extend and connect riparian reserves at headwaters for this overland connectivity concept. And you might think of headwater reserves as bundling many headwaters together. But if you go over ridge lines, you can start doing connectivity to opposing watersheds that may have no aquatic connectivity because they drain into the ocean parallel. Bridging those types of overland ridge lines could be very important for a whole variety of organisms, whether they be partly aquatic or terrestrial. In the density management study design, we see some examples of extending and connecting through riparian networks across terrestrial landscapes. We can see in this example, there's a BLM square that is somewhat visible through the thinning. And diagonally across that square, there is a line, and that's a stream that's connecting along the diagonal of the BLM square. There's also some stream riparian areas connecting sideways up to the flat part of the square. Extending and connecting those riparian buffers are a design element that you can add to your toolbox. Just like today, we've been adding so many different things to our toolbox for managing Northwest and West Side forests in particular. Extending and connecting riparian reserves is one more tool. You can think of these riparian areas as being funnels. They funnel a lot of organisms because they provide habitat not just for aquatic but terrestrial organisms as well. And then the chains are funneling the organisms along those corridors and then up and over ridge lines to the next drainage. Funnels and chains. In the Northwest Forest Plan, the shortest distance across a ridge line is in the headwaters, and I mentioned that before. So if you want to be economic and do some connectivity but not manage very much land, then that over-ridge connection across headwaters doesn't take up very much real estate. Kelly Burnett and I did a thought model of how this could work in the Oregon Coast Range landscape. And I won't go through the details. If you're interested in the details of this thought model, it's published and I can provide that to you. But we cookie-cuttered the landscape into watersheds, and there's a coding of watersheds, 4th field, 5th field, 6th field, 7th field watersheds, hydrologic unit codes. So we cookie-cuttered into different size watersheds. And then we zoomed in on some of the smaller watersheds. Here's the Siuslaw River Basin. That's a 4th field watershed. And it's cookie-cuttered into 6th fields. The duck-shaped one there is a 6th field. And we're going to zoom in on that in just a minute. And then those are cookie-cuttered into even smaller watersheds, 7th field. Our what-if scenario is, what if we connected each 6th field with each neighboring 6th field one time? Okay, at the headwater, we went from one headwater on one side of the ridgeline to a headwater on the other side of the ridgeline. One link across each 6th field watershed. That's one link every 9.3 kilometers squared. And then we did this scenario at the 7th field scale as well. And here is the 7th field scale. For the entire Coast Range province, if we were to do this, it results in 5,000 links across the coast province. And that at the 7th field scale is 15% of the headwaters being linked together. Unfortunately, there's no rule of how much connectivity you need in a landscape. But as I've queried people, how much would be a good start? For conservation, how much of the landscape would you set aside? Well, in the 10 to 20% range is where a lot of the answers came as a beginning for connectivity. It would be lovely if we could get 10 to 20% connectivity for things like spotted owls or other organisms. So here is an example, a thought model of how we could achieve 15% connectivity at a 7th field scale. You would get less if you went to a 6th field scale. So I'm going to go through some considerations as you think about linking landscapes and also linking aquatic and terrestrial resources. At very large scales, at landscape scales, it may be important to link discrete watersheds. So watersheds that do not have any aquatic connectivity at all, they drain into the Pacific Ocean and they don't drain into each other. Those might be important types of areas to have linkage areas across, connectivity. In our Coast Range and in the west side of Oregon and Washington, there's only a few places that actually connect 3 discrete watersheds. And I've called these triads. It's where you have a point on the landscape where you very quickly can go over a ridgeline and get to 3 different discrete watersheds. You can look at how these large-scale watersheds intersect, and the map there with the squares on it shows you where some of these triads are in Western Oregon. There's not very many of them. This would be an example of a potential priority area for linkage areas, for connectivity. This is where you can link across main watersheds to provide dispersal corridors to allow organisms to get into whole new areas. Another consideration, if you are thinking about climate change projections, then if you cookie cutter the landscape into watersheds, well, let's think about the northern section of that watershed, the southern section of that watershed, or if it has an east or a west side to it. Those are boundaries that would be perhaps priority areas to be considering for connectivity in a climate change context. So here I've overlaid those scallops with the 7th field connections across headwater ridgelines. Another consideration, on your landscape you have landslide prone areas. Those are areas that are really important for aquatic resources. Many of those occur in headwaters. Those are part of your riparian reserves, or they could be part of your riparian reserves. Managing those and using those as jump-off points for your terrestrial connectivity, connecting one area that is landslide prone across the ridgeline to another riparian area, that would make sense, and you could piggyback these different types of considerations together. So this laundry list of things that you might consider, ideas that you have in your toolbox for connectivity, can be quite extensive, and it goes on and on. These are just a few examples of what we've laid out in our paper. When you get to the ground, how do you actually do the connection? Well, green tree retention. We've heard lots of ideas of how you retain trees in gaps or in leaf islands or in dispersed or aggregated retention. Those are all tools that can be considered for connectivity. Connectivity does not mean leave it be. It could be a managed connecting corridor. It could be leaf islands. It could be thinning. Those are tools that you can use for connection. Now, depending on what your goal is, if you're trying to maintain connectivity for something like a flying squirrel or a red tree vole, you might actually need to have some tree canopy connection to help them disperse if they are dispersal limited. For ground-dwelling organisms, directional felling of logs is another tool in your toolbox. Recruiting that down wood and directionally felling it away from the stream or to the stream can aid the movement of organisms from the riparian area up and over ridgelines. In a BLM landscape, if you're dealing with checkerboards, you need to think of your diagonals. These are the diagonals of connectivity. Those diagonals are really important to maintain connections across the federal landscape because we don't know what's going on those other squares. Again, it doesn't mean you're retaining all trees across the diagonals, but you're considering that those are the directional dispersal movement corridors for a lot of organisms. And if you can think of those diagonals and connect them to the stream, maybe not at the very tip of the headwater, but anywhere along a stream, that will aid that connectivity of things along the riparian corridor up and over ridgelines to the next either BLM square or watershed. So we've been looking and thinking of these concepts with amphibians, and here are some acronyms of species names and how far amphibians go in a forested landscape. These data happen to be from pitfall trapping because a lot of salamanders and frogs are very cryptic in the forest. You just don't see them. But if you put a pitfall trap out there, you do collect them. They can travel 400 meters away from streams very easily, most of the species that we have in the west side. On the density management sites, we've been doing some case studies of looking at animals and their movements, and these are salamanders. We put out cover boards, and then we can check the cover boards to see if the animals are there. Because these salamanders are so cryptic, they live in association with down wood. And it's very difficult. You'd have to pretty much destroy the down wood to see if they live there. So we were starting to test these alternative monitoring schemes, and a double-decker cover board has 2 layers, and the salamanders seem to go between the layers of the cover board. And so we've been tracking them and looking at the movements of salamanders between cover boards at a couple of the density management sites. And so here's just some examples of individual salamanders as they are moving between boards. And it's very exciting. We are seeing quite a bit of movement. Most animals aren't moving very far. We're not really seeing any directionality in the movement, with the exception that the animals that are really moving are close to the stream. So there's like a hub of activity. It's like a little salamander city near the stream, and fewer animals are out in the rural area upslope, but there is still some movement of animals upslope. And so I'm going to leave you with these ideas really as sort of designs for connectivity across landscapes and starting to integrate aquatic and terrestrial resources together. And I have a movie, if it will play, just to give you a little sense of what could be happening out there in your riparian areas. So let's see. A picture is worth 1,000 words. Let's see if this will work. So she's going to lift up the cover board, and can you see the salamanders moving? Okay, there's a couple right in here. And I believe there was another one up by Loretta. This is Loretta Ellenberg, who helps me in the field. And so the idea is that, well, these animals are very attracted to these cover boards. There were 3 underneath this one cover board, and this was taken in June of this year. So it was actually, a wet, late spring. There you go, another. And So these animals are dispersal challenged. They're not moving very fast, but they do move, and they're highly associated with downwood. So here's where the concept of recruiting downwood and doing some directional felling can aid the movement of these animals across the landscape. So, and I thank Mark Blaine of University of Oregon for that video clip. And that's all, and we can answer questions out in the lobby, or if you have any quick questions, I can answer it now. Thank you.